Alright, so we're going to find the mean and standard deviation. We want to enter x. X is your variable. And list 1 is your probability. So we're going to enter those into list 1 and list 2. So hopefully you have your calculator and you can use it. I'm going to show the formula for the mean. I need a better color than that. The variable is x, so we put an x there. When we do two variables, when we combine two variables, we saw this on Monday, we use x's and y's and t's and c's and b's, just like in algebra. Standard deviation, a little more tricky. We got to find the mean. And I think you end up with 14, is it 14.65?
Yeah.
Okay, thank you. Alright, so there's the mean. Standard deviation. I'm not going to write out the whole entire formula, but it's good to know the standard deviation formula. We're going to take the first value, the first x value, minus the mean, and square it, and multiply by the probability. Times point, that's a decimal, 0.25. That's supposed to be a 5. Okay, there we go. Plus the second number minus the mean, plus the third number minus the mean, and so on. So we put dot, 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 representing all the other numbers, and then the last number, 18 minus the mean. That'll give you the standard deviation. Measures the spread. The average difference. Standard deviation is the average difference from the mean. So we add them all up, we square, and then we square root. That'll give us our average. The difference comes from subtracting. We find how far away 13 is from 14.65. How far away 18 is from 14.65. We square those numbers because we don't want negative numbers, like this would be a negative. So we square it, and then square root kind of eliminates the negative numbers. So that's the measurement of the spread. And I know that I have the mean and standard deviation on the next slide, so I'm just going to advance. Standard deviation 2.06. Alright, awesome. Okay, so now we know the mean and standard deviation. What we're going to do is transform the random variables. We're going to take and multiply. Okay, if college charges $50 per unit and $100 in tuition fees, create a new probability distribution. Find the new mean and standard deviation. So we're going to create so this is the probability distribution right here. We're going to create a new one based on how much money. So X is your college tuition. Let's call a new variable Y. Y equals tuition cost. In other words, dollars. The cost of college. You take it for free in high school, or you could pay a whole bunch of money and go to college. Oh, and don't ever fail classes. I get students all the time that fail their class. It's a waste of money. You put all this money into it and all this time, and then you fail it. I'll just take it again next year or next semester. What a waste. Waste of money. Don't do that. So make your new probability distribution. So we're going to transform 12. So the formula would be for Y, we take X and we're going to multiply by $50 times X. And then we're going to add $100 in tuition fees. So this is the algebraic formula to represent Y. So find the mean of Y and the mean of, or standard deviation of Y. So first you got to make that distribution. So let's go ahead and make the distribution. So again, you're going to take $12, multiply it by 50, and add 100. That'll give you how much it costs for 12 units. It's not the exact amount. I think it's $50 per unit. I think Hancock was down to $30 per unit, and I think if you're you're right out of high school, I think they waived the tuition fee. Or you had to pay a tuition fee, but I think they waived the cost per unit fee last year. Thank you. So see, 12 times 50 is 600, and plus 100 is 700. 13 times 50 is 650. Plus 100, I think, is 750. And then 800. And you can see the pattern. Once you get the first few, see the pattern, you're just adding $50. Let me make sure I did it right. Yeah, I did it right. So the question is, find the mean and standard deviation. So we could enter into our calculator. We're going to enter list 1, just like we did in the first problem. We're going to enter, that's already in list 2. So all we have to do is change list 1 and find the mean and standard deviation for x and y. So we already found x, just y. See, all these colors are looking funny on the orange. Okay, so our mean is take all the units and multiply by the probabilities. That gives you the mean of x. Take all your dollar values, multiply by those probabilities. That gives you the mean of y. Or you enter list 1, list 2, one variable stats for list 1, list 2. Hopefully you're following along, and get your mean of y, mean of x, mean of y, standard deviation of y. Or we could use the shortcut. Okay, and the shortcut I mentioned Monday. What we could do is, if this is true for the x values, this is true for the means. So we take the mean and multiply by 50 and add 100. That'll give us our mean of y. So we're going to do 50. It works out the same way, and you'll find it when you do one variable stats for list 1 and list 2. So you can add and you can multiply values times the mean. The mean is just like any x value. So if we multiply that out, we get our mean. And standard deviation doesn't work that way. Standard deviation, if we add a number to standard deviation, then standard deviation remains the same. In the example I gave, just a refresher, if I got some numbers, 5, 6, 10, and I add a value to each of those, I'm going to add 6, 11, 12, 16. What's the spread of those numbers? Well, in the first data set, 5, 6, 10, the standard deviation is about 2. And in the second data set, the standard deviation is about 2. Adding a value has no effect on standard deviation. The spread of those numbers are the same. The mean changes. The mean for this data set, add 6, and you get the mean for that data set. So the mean is affected just like you think it would be affected. You could add and multiply by the mean, any value. Standard deviation we can't. All we do is we multiply by standard deviation. So standard deviation is 50 times the standard deviation, 2.06. So there's your mean and standard deviation. And So I wrote the formula up there. The mean tuition is 100 plus 50x. Standard deviation is just 50x. 50 times your standard deviation. And what did we get? Did I write it down? No, I didn't. Kind of blurry, but
you get 832.5.
832.5. Okay. So the mean is 832.5. That's the average cost of tuition. It's in dollars, so we're going to put a dollar sign on there. And it's 50 cents. Okay, 0.5 means 50 cents. Because we have dollars and cents. And standard deviation of y?
It's about $103.
$103, okay. Alright, and then we can take, once we've done that, thank you, Jesus. Once we've done that, then we could find or apply a normal distribution. Let me apply a normal. Oh goodness, got the sneezes today. Alright, we can apply a normal distribution now. And answer some questions about this data set. What percent of students pay over $1,000 for tuition? Well, that's somebody that's taking a lot of units, right? Is it 15 units, 16 units, 17 units? We could decide how much in units, and we could decide how much in dollars. So, if it's a normal distribution, draw the curve. Put the mean in the middle. So 832.5 goes in the middle. And then 1 deviation and 2 deviations. So I'm going to do 9. We're going to continue to review normal distributions. Really important topic. We're going to use normal distributions when we get into chapter 7, 8, 9. Okay, about. Okay, I just estimated. I got rid of the 5 cent or 50 cents. We don't use coins anymore, remember? There's a coin shortage. Alright, so what's the probability of spending more than $1,000 in a semester? So 1,000 is right over here. So we're gonna find, I'm gonna use better color than that. Find this blue shaded area. It looks like it's going to be a small percentage, maybe like 5% or something like that. 5% of students spend over $1,000. So 1,000 is right here, about 1,000. So what's that probability? We calculate the z-score. So z equals, that's not a z. Need my other drawing tool. Z equals z-score. Take $1,000, subtract the mean, 832.5. This time I'll use 0.5. Divided by the standard deviation, which is about $103. That'll give us a z-score. So let's calculate that z-score. 1,000 minus the mean divided by standard deviation 1.62, 1.63. So I'm going to look up that z-score, a z-score of 1.63, and that'll give me my area to the left. It's always the left tail area. So we got to go to the very, very back of the book. I bookmarked it with a piece of paper in the back of my book. Z equals 1.63. Table 2, table A. T2. 1.62 is 0.9474. So this area to the left is 0.9474. That is not the answer because it says, the question is, find the probability of costing more than $1,000. What percent of students spend over $1,000 for tuition at the college? So that is over 1,000. We want above 1,000. That's this area. So we're going to do 1 minus 0.974. I know I didn't use all the notation that we usually do, but this is just showing in a picture. 0.05. Well, I was pretty accurate. I said about 5%. About 5% of college students will spend over $1,000. What percent is, you could transform that, okay, a z-score of 1.63. This would be kind of a higher level question. A z-score of 1.63, how many units is that? So a person taking that many units, we just transform it back. So using the z-score formula, z equals x minus the mean divided by standard deviation. So we use the mean number of units, so 1.63. We're trying to figure out how many units that is. The mean is 14.65 in units. So it's just working backwards in the z formula, 2.06. And we call it the x formula. X equals the mean plus the z-score times the standard deviation. If you solve for x in the formula, multiply by 2.06. That'll give you the number of units that you spend over $1,000. How many units is $1,000? Well, we could see, I know 1,000 is right here. 1,000, that was 18 units. So anybody of 18 units or above would be $1,000. So if you multiply that out, you should get a number of about 18. It's possible to take 19. I think I had 21 units one semester when I was in college. Pretty tough to do. You can't work or have a life if you take 21 units. Your life's dedicated to school, pretty much. So this is one variable. Okay, transforming one variable. We'll get to two variable transformations in a little bit, but this is just transforming one variable. So page 362. Let's look at page 362. Grab your book. Check your understanding. This is the cars that we talked about previously. The number of cars sold and the probability of selling that car. So if the mean is 1.1 and the standard deviation is 0.943, this is the problem from 6.1, same problem. The probability of selling a car on a Friday morning is 0 cars 30% of the time, 1 car 40% of the time, 2 cars 20% of the time, 3 cars 10% of the time. Suppose the dealership's manager receives a $500 bonus from the company for each car sold. Let y equal the bonus received for car sales during the first hour on a randomly selected Friday. Find the new mean and standard deviation. So we're going to calculate the new mean. You get $500 bonus for every car sold. So if you sell 2 cars, $1,000. We can rewrite this distribution like we did with the units. We don't have to though, because the mean of y the mean of y is $500 times the mean of x. I should phrase that better. Let me put mean x. The transformation y, you represent the transformation with just like an algebra equation, 500 times x. And we use capital letters to represent these transformations. So 500 times the mean of x. The mean of x is 1.1, so we're going to do 500 times 1.1. I think it's $550. You expect to make $550 on a Friday morning. So that's the mean. Standard deviation, what's the new standard deviation? We're not adding or subtracting any numbers from standard deviation. So all we need to do is multiply by 500 times standard deviation. The same rule applies to standard deviation. Because if we add or subtract, we cannot add or subtract standard deviation, but we can multiply 500 times standard deviation of x. That'll give us the new standard deviation. Again. All right, and whatever that is, 471.5. There's your new mean and standard deviation. Again, we can answer questions about that. We could say, what's the probability of making more than $700? Probability x is greater than 700. So we would apply a normal distribution for that. I forgot to mention using normal CDF. Normal CDF is the shortcut using the calculator. So this rule, multiplying by a value, applies to means, applies to medians, applies to IQR, interquartile range, applies to standard deviation when you multiply or add. Or I'm sorry, if you multiply or divide. If you add or subtract, it does not change the spread, does not change the range, does not change the IQR, does not change the standard deviation. Okay, and these 2 points are made on page 360 and 361. So in the box, look for the box on page 360, the effect of a random variable of multiplying or dividing by a constant. If you multiply or divide by a constant, you multiply or divide the measure of standard. They usually call that variable b. B is your scalar multiplication. You can multiply the mean, you can multiply the standard deviation by b, and they use absolute value of b. So if b is negative, then we just use the positive value of that, absolute value of b. Does not change the shape of the distribution, so your shape does not change. If you got symmetric distribution and multiply by $500, the shape of the distribution is still symmetric. To encourage customers to buy cars on Friday mornings, the manager spends $75 to provide coffee and donuts. The manager's net profit on a randomly selected Friday is the bonus earned minus $75. Find the new mean and standard deviation. So let's call this coffee and donuts. In the book, or even on the AP test, they usually use T to represent a new value. So T equals $500 times X minus $75. The money that you spend, this is the total amount. You spend $75 on coffee and donuts every Friday morning for your employees and for your customers. Mostly the employees, though. The employees end up eating them all, the donuts. Anyways, we have our transformation. This is the transformation. That's the formula for the transformation. So we're going to multiply the mean times 500 and subtract 75, which we already did. We already multiplied by 500 times the mean. We got 550. So now all we need to do is subtract 75 from 550, and we get $475. So the mean of T would be 500 times the mean of X and that is $475. Yeah, $475. The standard deviation of T, now we cannot add or subtract any value times standard deviation. If you add or subtract a number from standard deviation remains the same. So for standard deviation, we don't apply that transformation. We just apply, for standard deviation, 500 times X. So 500 times the standard deviation, which is 0.943, stays the same. You don't subtract $75 from every car sold. I just said don't subtract, and I almost wrote it. Okay. We don't subtract $75 from every car sold, so the standard deviation remains the same, 471.5. That's the effect of subtracting a value from standard deviation. So this is kind of shown on, again, at the bottom of page 362. If you add or multiply by a value times the mean, then we would do that times every value. We do it times the mean. If we add or multiply a value, we only multiply times standard deviation. Alright, cool. Now you're ready to do the first 10 problems on the homework. Hopefully you started on the homework. I hope that you started, got a head start. So there it is. Mean is y equals a plus bx. Standard deviation is y equals bx. Bottom of page 362. Combining random variables. So this gets into a new topic, combining random variables. Now we have an x and a y variable. Okay, if we have two different variables, can we add the means together? And the answer is yes. So the mean total, I wrote mu t equals mu x plus mu y. So we combine random variables, we just add means together. The formula for standard deviation is not adding standard deviations together, it's adding variances together. We'd add variances. Standard deviation squared equals standard deviation of x squared plus standard deviation of y squared. So that's the rule for standard deviation for combining random variables. Page 367. For any two independent random variables, x and y, if t equals x plus y, then the variance is standard deviation of t squared, standard deviation of x squared, plus standard deviation of y squared. And I introduced this on Monday with the problem that we did on Monday, the 2005 Form B. So you can go back and revisit that 2005 Form B and look at how standard deviation is affected. Okay, so the example on page 368, combining random variables. We're almost done, by the way. We're just going to go through this example, and then we're going to do the check your understanding problem, and we'll be done. So I know, Jason, you got to go, and somebody else left, but we're done soon. It says that SAT math scores and SAT reading scores find the mean total. So if you score 500 on math and you score 500 on English or reading, then your average score is going to be, your score is going to be 1,000. But if this is the average scores for two different groups, then we could just add those two means together. So 519 plus 507 is 1,026. Again, page 368. Okay, these scores, even though they're not independent, I'm just want to find, by using the formula, find the standard deviation for x and y. So the rule is apply standard deviations. Let me use a better color. Blue not working too well. Standard deviation of t total and again, I mentioned it kind of looks like the Pythagorean theorem. A and b squared equals c squared. So then we square root both sides to come up with standard deviation of t. So what I want you to do right now is just plug in standard deviation of x, which is 115, standard deviation of y, which is 111, into this formula. And we cannot just add the two numbers together. 226 is not this standard deviation. It's going to be a little less than that. I think it's a little less. $159.83. Pretty close to 160. We use whole numbers for SAT score usually. Standard deviation for math score was 115. Standard deviation for reading score was 111. So combined standard deviation would be 160. So if you look at overall, the mean is 1,026 with a standard deviation of 160. And there's Pete's and Aaron's Jeep tours. I'd encourage you to read that example on page 368 when we sign off. But we're going to do the check your understanding on, we're going to find the mean and standard deviation for a combined random variable. Now we've been buying cars. We've been buying cars from the car dealership. Now we're going to lease cars. So how much money you make off the lease. So let's do page 370, check your understanding. I want to give you about, I'm going to give you 5 minutes to work on it. And then I'll go over it. And then we're good. We're good for the day. All right. So the means are just what you think they are. You just add them up. 1.1 plus 0.7, 1.8. So you expect to sell and lease 1.8 cars that day. So it's a lease. Standard deviation. We cannot just add 0.943 and 0.64. We have to do the formula. 0.943 squared plus 0.64 squared. You should get 1.14. So I got 1.8 for this. And 1.14 for that. So make sure you check that you got that. And standard mean. So you get $500 for every car sold. You get $300 for every lease. So car lease, I would not recommend to lease a car because you don't get to keep it unless you want to pay it off. Or let the repo man come and get it if you miss your payment. 500 times the mean of X, 500 times 1.1 plus 300 times 0.7 will give you the mean of B. B representing the total amount that you're going to bring in. So it says at the very bottom that the total bonus B. Okay, so B is your bonus. Standard deviation, we can't just do that. So standard deviation was a tricky one. We got to multiply 500 times 0.943 and square it. So yes, we square the 500. You could do it two ways. You could do 500 squared times 0.943 squared, or you could do 500 times 0.943 first. It's in parentheses, and then square it. You get the same result using the rules of exponents. And 300 times 0.64 squared. So we get $760 for this one. Again, double check. I'm not putting it, showing, well, I showed it. You just got to plug in the numbers. $760 over here. And over here we get $509. So these T is cars sold and cars leased. B is bonus. So we get $509.09 when you do this math. Bam. All right. Then the other thing that you'll have to know is finding the mean difference, and we'll get to that tomorrow. Finding the mean difference, calculating the mean difference, and then the standard deviation for the differences, and then doing some normal distributions with differences. Okay, so the differences are very, very similar to the means. You just subtract, and then you add variances for the mean difference. All right? Okay, that's it for today. Any questions about anything?